Hello Year 9, welcome to our session on how to do exterior angle sum of a convex polygon. Sounds complicated. Well, let's have a look. Let's cope with this one at a time. Firstly, we have a look at what a convex polygon is. And if you remember from last time, that's a polygon where all the angles point outwards. So like this one, all the angles point outwards. So that's what we're dealing with. Convex polygon, exterior angle sum. That's the next thing. So how do you get them? Basically what you do is extend each line out, same direction. So there's our exterior angle there. Then next line, so you have to keep on going the same direction. Exterior angle there. Next line, extend out, because you should end up with this line we extend out, and we're doing that one there, and this one comes out. You should end up with the same number of external angles as the number of sides. So we have 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5 external angles. The good thing is that with this, the sum is always 360, no matter how many sides. So the sum of the exterior angles with this one is 360 degrees. The sum of the exterior angles in this one is also 360 degrees. No matter how many sides there are, the sum of the external angles is always the same, 360. Okay, so let's have a look at first example. Regular hexagon, 6 sides, 1, 5, 6 sides, and so that means that there are 6 external angles. I'll just do one quick, one there. You can extend this one out. Oops, one there. Out here and so on. External angles, there's 6 of them. So all we have to do is take the total, 360 degrees, always 360, and divide it by the number of sides. Equals 60. Okay? So each external angle in a regular hexagon is 60 degrees. Total, always the same. Any polygon divided by the number of sides. That's 60. This one here, each interior angle, this is from the last section. So what you do is you go the sum of angles of this one, 186 sided, 180 times 6 minus 2, that's 180 times 4. So the total is 720. That's the angle sum of the inside angles, interior angle. Total is 720, that's how you do it. And that means that each angle in a regular hexagon is the same, so divide that by 6 is 120. So each external angle there is 60 degrees there, and each interior one is 120. Okay, remember external total is always 360, and you divide that by the number of sides to get the size of each exterior angle. The interior ones, you have to do this first to find its sum, because it's different. The sum's going to be the same no matter what. The sum is different. So we do this, and we found the sum interior angles. The sum is 720. Exterior, the sum is 360. Okay. Okay. Find the number of sides. For a regular polygon, if each exterior angle is 12 degrees. That's not very big, so there's going to be a lot of sides. So that's the total of the exterior angles divided by how many angles there are, 12, equals 30. 30, 60 divided by 12 is 30. So the number of sides, that is. So this figure has 30 sides, and each exterior angle is 12 degrees. Okay, next one. Find the number of sides if each interior angle is 160. Now, from last time, we realised that we have to do the angle sum and divide it by the number of sides, which is going to equal how much each angle is in a regular polygon. The angle sum, we don't know what that is. The number of sides, we don't know what that is. And the angle size, we'll give you the angle size, but it's told us what the angle size is. So let's piece together this, and then I'll show you what to do, because it's not going to be all this. So I know that the angle sum is this, of the interior angles, and putting that together with this, we come up with, there's our angle sum, 180 bracket number of sides minus 2 bracket over the number of sides, n, equals, well, it tells us what each exterior angle is, 160. So now with a bit of rearranging, what I did first was multiply both sides by n. That gets rid of this fraction. So all we're left with is the angle sum equals 160 times the number of sides. So that n's gone from there to there. And then I expanded the brackets. So that's 180 times n there. And then minus 180 times 2, which is 360, equals 160n. Then I move the minus 360 over to here, plus 360. So that leaves us with 180n equals 160n plus 360. And then I moved, what did I do next? Divided by 20. There's something else happened here. That's right, yes, I moved that over there. So take the 160 and put it there. That left us with only 20n. 180 minus 160 is 120. And then the left for 360 there. Then I divided by 20. The number of sides then equals 18. Number of sides there is 30. Number of sides here is 18. Now, that's a lot of work. And you will have to do it for question 4. But what I'm going to do is show you how much working you'll need to do. I'll just move question 4 up to there. See if that works. I'll get rid of what's underneath. That's just to show you how it all works. So your working for that one will start here. So what you do then, I'll get rid of that as well, because up to here it's going to be pretty much the same, except for, let's do the first one. Let's say the number of sides, if the regular polygon, each angle is 150. So all you do is these 3 lines are working. And I'll do this one. You start with 180n, same as that one. So I'm doing 4a. 180n equals, now instead of 160n, which we'll use for this, it's 150n. Plus 360. First line of working, put the angle size there. Second line of working, move that over. You're left with 180 minus 150 leaves us with 30n equals 360. Divide by 30, n equals how many? 12. So that's what you do for 4a. So instead of this, what I did for this example, you put, instead of that one, you put 150 instead. 4b, you'll put here 175, 162 and so on. Okay, lastly, let's have a look what we do. I've looked at question 4. Question 1, size of each exterior angle. Remember, it's always 360, so octagon has 8 sides, decagon has 10, 15, and nonagon has 9. So all you do for each one is 360 divided by how many sides? That's for question 1. Question 2, the size of each angle in a regular polygon, so you have to do the angle sum. 180 times the number of sides minus 2. So pentagon is 5. Decagon, remember that one, that's 12. Nonagon, that's 9 and a 16. 5, 12. Nope, it's right. Yeah, nonagon 9 and 16. So that's the numbers you put instead of n there. Number of sides of a regular polygon, if each exterior angle is. Number of sides, if each exterior angle is, okay? So 360 divided by, well that one will be 24. And that'll give you the answer to that one. 360 divided by 36, 360 divided by 40, 360 divided by 10, and so on. That's it. Thank you.